Hello. This mini lecture is to walk you through delta G calculations. You have calculations like this for practice, you have some on the homework, and you will see at least one or two on your quizzes and exam. So Chapter 8 quiz and Unit 2 exam. So I want to make sure everybody's understanding how to do these calculations. Alright, so you'll get a question like this. We're always going to calculate the delta G in. And then I'm always going to also ask you to state which require energy. So let's work through this first problem. It says the external concentration for ion Y plus is 20 times greater than the internal concentration. The external. For a cell at 37 degrees Celsius with no difference in membrane potential, what is the delta G? So delta G in, and I've given you the constants and the formula. Please make sure you write these down for your quiz. I think they're given, but just in case, make sure you have them. Okay, so let's just go through piece by piece. So we're going to calculate delta G in, and the formula is R, which is a constant, 1.987, and I don't do any rounding till the end. Okay. The temperature is always in degrees Kelvin, so if I tell you it's 37 degrees Celsius, to figure out degrees Kelvin, you need to add 273. So if we do this, 37 degrees Celsius is 310 Kelvin. Then, here's the tricky part, we're going to take the natural log of this ratio. So the concentration in over the concentration out. So it says the external concentration is 20 times greater than the internal. So if the internal, say, is 1, the external would be 20. Okay. Then, if it's an ion, like this is, we have to look at the Z Faraday, membrane potential part. So Z is always the charge. So you would have 1. The Faraday constant is 23.062. And the membrane potential, they say here, is no difference, so it's 0. So in fact, for this problem, we don't have to worry about this part because it would equal 0, 0 times anything. So what I do is I always calculate the natural log first. Let me grab my calculator, which of course I can't find now. That's weird. Oh, there it is. Okay, so what I do on my calculator is I plug 1 divided by 20. So 1 divided by 20 gives me 0.05. And then I hit the ln natural log button, and that's going to give me a negative 2.9957322, blah, 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 blah. So I actually don't worry about sig figs. I just throw this into that formula. So I always calculate this number first, then I multiply it by 310, and then I multiply it by 1.987, and I get not the answer that I came up with first. Hold on, what did I do? 1 divided by 20 natural log times 310 equals times 1.987 equals, okay, there we go. So I get a number minus 1845.28, blah, blah, blah. So you should see an answer that looks something like this. Remember, these answers are always in cals per mole. Or if we move the decimal place 1, 2, 3 over, it's negative 1.8 kcals per mole. Okay, so watch your units. I might give you an answer on a multiple choice either way. If you are writing these as homework, I expect to see all of this work. And you can leave it in cals per mole or kcals per mole, just as long as you state your units for full credit. All right, let's do another one. And what you might want to do is pause the video, do this one yourself, and then see if you come up with the same answer as me. So I'm going to do delta G in equals 1.987. The temperature, again, is 37. So plus 273 makes it 310. Then I do the natural log, and it says external is 20 times greater than internal, so in is 1, external is 20. And now this membrane does have a membrane potential, and we're working with an ion, so we need to include this part of the equation. So the charge is 1, positive, the constant, and the membrane potential, you've got to put in volts. So this is millivolts. So to figure out volts, we move the decimal 3 places. It's negative 0.06. So this is really the answer from our previous problem, negative 1845. And then if we do this calculation, 23062 times negative 0.06, oops, I don't know what I did, 23062 times 0.06 negative equals negative 1384, and we add these two together and we get negative 3229. Again, these are cals per mole, or negative 3.2 kcals per mole. Okay. So those are pretty standard. Always look to see if it's an ion. If it doesn't state that it has a charge, you don't have to worry about the second half. If there's no membrane potential, if that was 0, like the previous question, you don't have to worry about that second half. So a lot of these are pretty easy plug and chug. The last one I want to show you is when you get something a little different, and I always like to challenge you. So I might give you something that you haven't seen before. For instance, this problem says the internal pH is 4.0. The external pH is 7.0. For a cell at 25 degrees Celsius with a negative 130 millivolt membrane potential, what is the delta G for the proton gradient? You might look at this problem and go, what the what? Okay, so one of the things I want you to remember is protons in biology is H+. And hopefully you remember that the pH is talking about the concentration of H+. Okay, so they're related. So the pH equals the negative log 10 of the concentration of H+. So for instance, pH 7 equals 10 to the minus 7 H+ concentration. Okay, so when you have a pH number, you put that number as the 10 to the exponent, negative exponent, and that relates to your H plus concentration. And what we're trying to do is find the delta G for the proton gradient, so the difference in the H plus concentration. So let's plug this one in. So delta Gn equal 1.987. The temperature, so 25 degrees Celsius plus 273 equals 298 degrees Kelvin. So we got 298. And then we have the natural log of in over out. So the concentration in is 10 to the minus 4. The concentration out is 10 to the minus 7. This is an ion, so the Z is positive 1, F is 23062, and our membrane potential is negative 0.130 volts. So I plug in 10 to the minus 4 divided by 10 to the minus 7 equals 1,000. So I'm going to take the natural log of 1,000. I'm going to multiply that by 298 for the temperature and by 1.987, and I get a positive 4090. And then I, do this part of the equation, and I say 23062 times 0.130 negative equals negative 2998. Add these two numbers together, plus 4090 equals positive 1092 cals per mole. All right, so that is your delta G, but I asked for one other important part in this question, and that's to state, which requires energy. So if we look up at these numbers, if you remember, move this to green. If the delta G is negative, means it does not require energy. So this one will go on its own. This one will go on its own. But this one, because it's positive, you've got to make sure you say it requires energy. Now notice I didn't ask if it's exergonic or endergonic, which I could have, but I asked which requires energy. And so please be very specific to the questions I ask, because as I go through and grade homework, and you can imagine there's a lot of them, I'm looking for the keywords. Okay, so if I ask you which ones require energy and you say, oh, well, this one's endergonic, this one's exergonic, that's not what I asked for. I asked to state which requires energy. So do exactly that. And if you want to make sure you're complete, you can say no energy required, and the same, no energy required. Okay, I highly encourage you to do the practice problems before you take the Chapter 8 quiz. Like I said, there's also homework problems to work on. And let me know if you have any questions. All right, thanks. Bye.